Hey there, welcome to day one of the ACT Math Prep class. My name is Justin Jones, I'll be your instructor. All right, so let's go ahead and get started. So first thing we want to do is we want to define a variable. Okay, basically a variable is just a letter that represents some number. It's an unknown number, we don't know what it is. Really common variable there is going to be the letter X. All right, sometimes you'll see Y or Z, but it could be anything, A, B, C, it could be any letter. Basically any letter that's representing an unknown number that we don't know. Okay, so for an example, all right, how many basketball players are there in the United States? So we do not know the number of basketball players in the United States. So if we want to use that number, we're going to have to use a variable to represent it. So we're going to say, okay, there are B basketball players in the United States. So that letter B is representing the number of basketball players in the US. Okay? So you can use any letter. Of course, B is a common letter if you're talking about basketball players. But again, it could be X or Y or Z or any other letter. All right, so what we do with that variable is we kind of expand on that. So we add to that. We use operations. So before I get into that, we're going to talk about what an operation is. An operation is a mathematical symbol, like addition or subtraction or multiplication, division. We can do square roots, we can do squares. There's all sorts of other ones too, but those are the basic ones, the operations that we talk about. So what we can do is we can take a variable like B, the number of basketball players in the United States, and I can talk about what happens if 5 new basketball players arrive on the scene. So there's 5 more basketball players. Well, we want to represent that number, right? That number of basketball players now that we've added 5 people. So what we would do is we would just take B, our variable that represents the number of basketball players. We're going to add 5 to it. Okay, B plus 5. What if instead of adding 5, what if we took the number of basketball players and we cut it in half? Right? What would that be? That would be B divided by 2. That would be half of the amount of basketball players. Of course, another way to write that would be 1/2 B. Just represents half the amount of basketball players. So a few things here. We call this an expression. When we take a variable, operations, and numbers. So when we take a variable, mix it with operations, right? What are our operations? That's right, our operations are plus, minus, division, subtraction, all those things up top. When we take that variable and we add an operation, and then we also include numbers, actual numbers. What do we get when we combine all those things? We get what's called an expression, okay? So an expression is basically a combination of variables, numbers, and operations. When you combine those 3 things, you get an expression. Now don't forget, an expression still represents an unknown number. So we don't know the number of basketball players. Well, if I add 5 to that, am I going to know the number of basketball players then? No, it's still unknown. So expressions are usually represented by unknown quantities. I don't know how much half of the basketball players would be. So if I don't know B, I'm not going to know B plus 5. I'm not going to know half B. You're not going to know what an expression's value is, but we just have to know what it is as a fundamental mathematical idea. All right, so that's what an expression is. Unknown amount deals with variables, letters, and numbers. All right, so moving on, if I took 2 expressions and I said that they're equal to each other. So if I have an expression that is equal to another expression, so for example, 5 plus P, if that's equal to 1/2 P minus 7, okay, I just made these up. If I have this expression on the left, this 5 plus P, and I have this expression on the right side, 1/2 P minus 7, now we've moved from an expression into what we call an equation, okay? This is now called an equation. So anytime you have 2 expressions that are set equal to each other, you have an equation, all right? So here's some examples of equations and expressions together, okay? So over here, we're going to put expressions. Over here, we're going to write equations. So let's look at some examples of and the differences. We'll talk about the differences between the 2 things. So an expression, 58 minus 3z, okay? Definitely an expression. all right? On the other hand, an equation might say something like 5 equals 10 minus x. Okay, that's two expressions set equal to each other. All right, x squared plus x plus 10, that would be another expression. All right, x squared plus x plus 10 equals 0, that would be an equation. All right, one more example here, n plus 3 plus 7 divided by 3, that would be an expression. Over here, 5a minus 3x divided by p is equal to 10z. That would be an equation, okay? So what you're noticing here is one way to think about this is that, oh, equations have an equal sign, but it's not that simple, okay? On the ACT, they're gonna try to trick you with that. So a better definition would be an expression has a left side, and it could have an equal sign. So it might have an equal sign on the test. So you'll see things like 10x minus 7 equals, okay? Now you're gonna see an equal sign there. I don't want you to think that, oh, just because I saw an equal sign, that means it's an equation. There's a left side, right? You can see the left side, that 10x minus 7 is on the left side, and then you've got an equal sign. Now when I say left side and right side, what am I talking about? I'm talking about the equal sign is in the middle, okay? Equal sign is in the middle. The left side of the equation is anything that's over here on the left side of the equal sign, and the right side would be anything that's over here on the right side of the equation. So the middle is always the equal sign when we're talking about equations. All right, so just be prepared on the ACT to see things where there are what looks to be an equation, maybe, because you see something with an equal sign, but that's not the definition of an equation. An equation has a left side and a right side. Okay, if you look at these examples, oh, I just noticed they're covered up here. I'll have to move my face out of the way. But if you notice on these examples over here, every time I see an equation, all right, I've got a left side and a right side. So here's my left side, my middle is my equal sign, here's my right side. Okay, equations have left sides, right sides, and an equal sign in the middle. Again, here's my left side, here's my right side, there's my equal sign. Left side, right side, equal sign right in the middle. All right, so that's an easy way that you can tell the difference between an expression and an equation. All right, moving on. So let's talk about, in general, what are you going to do on this test? What are you going to do on the ACT when you see an equation or when you see an expression? What is your main objective going to be? Well, let's look at some examples here. All right, on the left side here, I'm going to put expressions. On the right side, I'm going to put equations. So there's basically two things you're going to be asked to do when you're looking at an expression on the ACT, okay? Let's just focus on expressions for right now. First thing you're gonna have to be able to do is you're gonna have to be able to simplify, okay? That is gonna be 85 to 90% of the time when you see an expression, you're gonna be simplifying, okay? That's a really, really big part of the test is the simplification, all right? The other thing you're gonna do is evaluate. Okay, you're either going to be simplifying or you're going to be evaluating. So let's look at simplifying. Okay, basically, when you think simplify, right, we simplify fractions, right? We simplify expressions, we simplify all sorts of things. But basically what you're doing is you're just rewriting, okay? You're just rewriting the expression in a different way, okay? So I'm going to put, you're rewriting in a different but equal way, okay? The whole thing is that it's equal. You're going to rewrite it in a different but equal way. So it's really going to be the same thing, it's just going to look different, right? So an example would be when you take a half and you rewrite it as 2/4, okay? They're the same thing, they just look different. So when you're simplifying, when you rewrite it, it's going to look different, okay? It's going to look different, but it's really going to represent the same thing, okay? All right, so evaluating. What is evaluating going to be more like? Well, that's when you're going to plug in a number for the variable. So you're going to have some expression, 3x, and you're going to know, okay, x is 10. So what you're going to do then is you're going to replace the x with that 10, and you're going to evaluate. Okay, the key word here is value. Value means number, right? Think about it. What's the value of this computer? Oh, it's a $100 computer. When you think the value, you're thinking of a number, right? How much is something worth? So remember that when you see the word value, you should be thinking number. So what we're going to do is we're going to plug in numbers. So I'm going to use this number symbol a lot. The hashtag means numbers, okay? Plug in numbers for the variables. Okay? And basically what that's going to give you is a value of the expression. Again, it's a number. What is the value of this expression? It's 10. Okay, and we'll look at some examples here in just a moment. All right, next up is equations. All right, don't forget equation has a left side and a right side with an equal sign in the middle. Right, that's how you always know it's an equation. All right, with an equation, there's two things you're going to have to do. The big one is solve. 90% of the time, maybe more, 95% of the time on these ACT test questions, you're going to be solving an equation. Okay, now sometimes you have to solve it and then do something with that number, but in general, that covers most of the things you're going to be solving. Right. The other option is you're going to answer a question. Okay, so those are kind of your two choices. You're either going to be solving or answering a question. So let's focus on solving. All right. So you're going to find the value. Again, what does value mean? Number, right? Value of the variable. So you're going to say, okay, x is equal to 10 in this equation. All right. So expressions, we didn't really find the value of a variable. Well, if we're evaluating them, we're finding the value of the expression. But with equations, when we solve, we're actually finding the value of the variable. I want to know what that unknown quantity is. What is x? Oh, it's 10, or it's 20, or negative 5. So that's ultimately our goal when we're solving, is to actually find the value of the variable. Now, a lot of teachers say this: we're going to get the variable by itself. And that is true. That is a strategy, okay, to solving. We're going to get the variable by itself. And once we do that, we'll be able to know the value of that variable. And again, we'll look at some examples in just a second. All right, answering a question might say something like, what is the slope of this line? So you're given an equation in the form of a line, and you have to manipulate it and then answer a question. Say, okay, x is equal to 7. Or excuse me, if it says y is equal to 3x plus 2, then you're going to say, okay, the slope of this line is 3. All right, other things you might be doing are like y-intercepts, or answering questions like, is it parallel to this line, or is it perpendicular to this line? You're going to be answering a question. You're not actually solving anything. So those are the two things you're going to do with equations: solving or answering questions. So just to recap, two kinds of things we're talking about: expressions and equations. With expressions, we're going to simplify or evaluate. With equations, we're going to solve, or we're going to answer some kind of question. Okay, so we're going to look at some more examples of this, and we will keep going. All right. All right, so first let's look at expressions. Okay, we're going to look at simplifying expressions. All right. So remember, simplifying means we're rewriting it in a different way, but to where it's the same exact thing. It represents the same quantity, but it just looks different. So we're going to change the way something looks. All right. So first of all, how do you know that it's an expression and not an equation? Right. We should be looking for something that has a left side but not a right side. There might be an equal sign, there might not. Okay. Here's some key words that are going to help you figure out, though, that you're supposed to be simplifying and not evaluating. Okay. When you see these key words, it should trigger something. Oh, that's simplifying. Okay. When you see these key words, think simplify. So seems silly, but yes, you will see this on the test. You will actually see the word simplify. It will say simplify the following, or just simplify. So if you see simplify, you're thinking simplification. All right, next one here, equivalent. This is a big one. Okay. If you see the word equivalent, which of the following is equivalent to? Or find an expression that's equivalent to this. If you see the word equivalent, you're going to rewrite whatever they give you in a different way. So you will be simplifying. All right. And then other things might be for all x, blah, blah, blah equals. Okay. Now this is going to be your expression right here. Okay. That's going to be your expression. It's going to say for all x, comma, this expression is equal to blank. And you're supposed to choose from the 5 choices which one of the following expressions is equal to the first one that they give. All right. Now, lastly, you might see this. It might just give you an expression and then an equal sign. Okay, like it might say 10x squared plus 5x equals. There's an example of what that might look like. Okay, now it doesn't say simplify, it doesn't say equivalent, it doesn't say for all x this expression is equal to. It just gives you an expression and then an equal sign. Okay, and that is where we're going to simplify. You're going to rewrite that in a different way. Okay, so one thing to remember whenever you're simplifying expressions, okay, we are living under this umbrella of PEMDAS. Okay, you probably all remember this. Please excuse my dear Aunt Sally. There's lots of acronyms that work for this, but it's parentheses, exponents, and roots. Multiplication, division, addition, and subtraction. Anytime we're dealing with an expression, not an equation, equations are different, but when we're living in expression land, we're always dealing with PEMDAS, okay? So just remember, PEMDAS is parentheses first. Anything inside of a parentheses you do first, then it's exponents, and technically an exponent is the same thing as a root, like a square root, so you do those at the same time. Let's see, multiplication, division, addition, and subtract. Now, don't forget, with these two, multiplication and division, you have to do them from left to right. You have to do them from left to right. If you do them backwards, it won't work. You always got to read it from left to right. Same thing with addition and subtraction. You got to go left to right. And we'll look at an example where we might use that in just a second. Okay? Very, very important that you remember when we're in expressions, we're dealing with PEMDAS at all times. You got to follow those rules of PEMDAS. All right, so simplifying expressions could be lots of things, okay? Some things that it includes would be factoring, okay? When we factor, we are simplifying, okay? We're rewriting it in a different way. So factoring could be an example. Canceling, right? When you cancel like a fractions, numerator and denominator, the top and the bottom, that's considered simplifying. Okay, any kind of distributing, or anytime we're just simplifying in general. Could be a fraction, could be an expression, could be a term, whatever. Anytime we're doing factoring, canceling, distributing, or simplifying, that's all under the umbrella of simplifying. Okay, so those are just some examples of things you might see. All right, now, you may have to, I'm going to put a star by this, you may have to actually set up an expression. Okay, you may need to actually set it up, and this can be kind of a tricky thing to do, especially with variables. Variables kind of make it a little tricky. So I'm going to show you a little trick that I use all the time to help with setting up an expression. Okay, you know, you'll see problems like this for sure on the test where they say things like write an expression that represents the following, and they'll tell you a little word problem, and you're supposed to set up an expression. Okay, so this is kind of like a trick. This is a little trick to try if you're having trouble. Okay, so first we're going to use numbers in a situation. So first we're going to use numbers. Again, my hashtag means number there. So we're going to use numbers first, and then we're going to switch out with variables. Oh, you can't see that. All right, so switch out with variables. All right, don't forget this little W with a slash. That means with. I'm going to use that a lot. Okay, it's pretty common shorthand. All right, so you're going to use numbers first, and we're going to switch out those numbers with variables when we don't know the value. Okay, so let's look at an example. All right, the average of a number and twice that number is an expression we want to find. Okay, so we want to find, as an example, okay, we want to write an expression for the average of a number and twice that number. Okay, the average of these two numbers. So what we're going to have to do is we're going to have to try some examples with numbers. So let's pretend instead of just a number, we're going to use a specific number. Okay, so let's pick the number 7. Okay, I want to find the average of 7 and twice 7. So I know that 7 plus 14 divided by 2 will give that to me. Now let's think about this. I picked the 7, right? I just picked that at random. You can kind of pick any number. Where did the 14 actually come from, though? If it's twice a number, I actually did some math there. So I want to write it out not as just a 14. I want to write it as actually what math I did. Okay? So instead of writing 7 plus 14 over 2, I actually want to write 7 plus 2 times 7. And then cut it in half. Now remember, I'm dividing by 2. If you remember averages, I add up 2 numbers, so you divide by 2. That's why we have a 2 on the bottom. But you see how I wanted to write, instead of 14, I want to write it as what math did I do? Okay, so let's try it with a different number. Let's pick the number 5. Okay, so same thing. What's the average of 5 and double 5, twice 5? Well, it's 5 plus 2 times 5 divided by 2. Okay, so now what we're looking for is a pattern. Okay, what did I do the same in both of these? Well, it looks like I have a number first, and then I double the number, and then I divide by 2. So every single time in this problem, I'm dividing by 2. And every single time, I take whatever number I pick, and I add it to 2 times that same number. So now let's go back, now that we've tried it with numbers, let's try it with just variables. So pretend we don't know the number. So we're not gonna pick a 7 or a 5. We're gonna use a variable. So let's pick x. Okay, so now we're going to do x. That's the number. So x, just like I put a 7 or a 5 here, I'm going to put the number, which is x, because I don't know what it is. Notice both times I put a plus there, so I'm going to put a plus here. Now I'm going to do 2 times that number. So 2 times x. Well, remember, how do we write 2 times x? We just write 2x. And then, of course, every time I divide by 2. So you see what I did there? I tried it a couple times with numbers to see what I'm actually supposed to do. And then I converted, instead of using those numbers, I used just a general variable. And that helps me see what I'm actually supposed to do to build this expression. So what I did was I built an expression that calculates the average number of a number and twice that number by using a trick where I pick numbers instead of variables. And then at the end, once I see how it works, then I use the variables. All right? All right, very, very good. All right, moving on. All right, let's look at another expression here. Okay, another way to use this trick. We're going to try another example. All right, this time I want to write an expression for the total cost. All right, that's an F there, of buying hot dogs and brats. Okay, I want to know the total cost of buying hot dogs and brats at let's say at a basketball game. All right, this is at a basketball game. All right, and we're going to say that hot dogs cost $3 and brats cost $7. Okay, so I want to write an expression for the total cost of buying these hot dogs and brats. I don't know how many I'm going to buy, but I want to come up with an expression that represents that number. So let's just come up with an example. All right, let's use numbers first. So let's say, okay, let's use 4 hot dogs and 4 brats. So how would I find the total amount of money that I spent? Well, I need to find the amount of money that I spent on the brats and the amount of money I spent on the hot dogs, and then add those together. Okay. So what I might try to do is say, okay, it's $3 times the number of brats. So if I bought hot dogs, so 3 times $4, okay, plus $7 times 4 bratwursts. That would be an expression that calculates the total cost if I bought 4 hot dogs and 4 brats. Okay, let's try a different number set. Let's say I buy 10 hot dogs and 12 brats this time. Okay, this was for 4 hot dogs and 4 brats. So what would it be? What would be the same here? The 3 or the 4? I think the 3 would, because that's the cost. So it'd be 3 times the number of hot dogs that I bought, plus 7 times the number of brats that I bought. Whatever that expression is, and again, I don't care what that number is, I'm just trying to see how it works. Okay, so once I've tried a few examples with numbers, now I'm ready to convert it back to variables. So where am I going to put the variables at? Well, wherever the things change, right? This 4 changed to a 10, so I'm going to change it to a variable, right? This is the thing that's changing. Remember, variables are flexible. They're allowed to change. So that's where our variables are going to go, wherever the things are changing. So what I'm going to do now is I'm going to write, okay, 3 times the number of hot dogs that I bought. Well, let's use X for hot dogs, okay? Plus 7 times the number of brats that I bought. Let's put Y. Now you could see an H, or you could see a B, right? H for hot dog, B for brat. That's pretty common. Or you could see things like X's and Y's or A's and B's. Usually they'll define in the problem what they want the variable to represent. But that's it. That expression right there is going to calculate the total amount of money spent based off of buying X hot dogs and Y brats. So just to remind yourself, this is the strategy. If you're having trouble building an expression, try it with numbers first. Then look at your examples. Like, what did you do here? What did you do here? Well, just do the same thing here, but instead of numbers, right, where you picked numbers, you just leave it as variables. Okay? All right, moving on. So that was simplifying, okay? That was a strategy to help us simplify. Now we're also gonna have a testing strategy that's really, really good, and it's gonna help us simplify expressions using some kind of non-traditional methods, and we'll see how to do that on week 2. But for now, we're gonna continue on. All right, so we're gonna talk about evaluating expressions. All right, so remember, what is the word evaluate? What word is in there, right? Value, a number. When we evaluate, we're going to come up with a number. So how are you going to tell, sometimes that's the hardest thing of the ACT is like, what am I supposed to do in this problem? So how are you going to know? Well, first thing, if it's an expression, what are you going to not see? You're not going to see a left side and a right side. You're just going to see maybe a left side or a left side and an equal sign, right? But also, how do you know you're not supposed to simplify? Well, what you're going to see is they'll give you values for the variables. So they'll say, they'll tell you that X is equal to 7 or X is equal to 3. They'll tell you what you're supposed to use for the variable. So that's when you see this little piece tagged onto the end, you got to think, okay, that's what I'm doing. I'm evaluating. All right. Here's some keywords to help you also. If it doesn't immediately, if you don't immediately see it, okay, here's some keywords. Right? You'll see this phrase here. What is the value of blank if X equals this and Y equals this? Right? What is the value of, and then they'll give you an expression, and then they'll say if X is equal to 2 and Y is equal to negative 1. Okay? What is the value of this expression? So maybe it says X squared plus 2Y, right? But they'll tell you what X and Y are. That's the key there, is to see, okay, what is the value of this expression under these conditions? All right. Also, they'll literally use the word evaluate. They will say evaluate the following expression if X equals this and Y equals this. Okay. All right. So let's look at an example. All right. Let's say find the value of 3xy squared plus X if X is equal to 3 and Y is equal to 10. Okay, so when we're evaluating, what are we doing? We're going to plug in the value of those variables into the expression. Okay, pretty much in math, anytime you know the value of a variable, if you know that X is 5, well, you should immediately plug that into the equation or whatever you're working with. You shouldn't waste time. You should immediately do it. That always is what you want to do. So let's take our expression, 3xy squared plus X, and let's replace those variables with numbers. So don't forget, what does 3x really mean? There's a word we're missing there, 3 times X. That's multiplication, okay? So when we write it, we want to write it with multiplication. And the easiest way to write it as multiplication is to put parentheses around it, all right? Using parentheses is really, really important, especially if you're using your calculator and you're dealing with negative numbers. Always, 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 when you're evaluating, put parentheses around your numbers, especially in your calculator. You can easily run into some problems where it'll switch things around and give you the wrong answer, okay? All right, so X is 3. Oh, made a mistake here. X is 3, so I shouldn't plug in 10. I should plug in 3, okay? Times Y, which is Y is 10. And don't forget, we want to square that. So I got to put my little exponent up there. Plus 3, okay? Now, if I want to be safe, put a little parentheses around, doesn't hurt. Now, remember, when we're simplifying, we're living under the world of PEMDAS. So I need to be thinking parentheses first, exponents, multiplication, division, addition, subtraction, that order of operations, right? So the first thing I should do here is I should square the 10, okay? First thing, if you try to multiply 3 times 10, you'll get a number and then you square it, it's gonna be wrong because you're not following PEMDAS. So the first thing I should do is simplify that 10 squared, makes 100, okay? Now I should do multiplication. That would be the next thing. Remember, left to right. So 3 times 3, which is 9, times 100 is 900. And then I have that plus 3 at the end. My last step is going to be to add. 900 plus 3 is 903. So that would be your answer. Okay? But remember, it says find the value of this, but then it gives me these conditions. It tells me what x and y are. That's how I know that I'm evaluating. Okay? That's how I know I'm not supposed to simplify here. All right? All right, moving on. Next thing is equations. All right, so first off, you may have to set up an equation. Okay, be ready for that on the test. And we'll go over some things, I think on week 3, where we talk more about the language of math and what each word means, and that'll kind of help you build equations. But again, you can use that same trick that we did with expressions, right? Where we used numbers instead of variables. Just try it out a few times, right? Make up some numbers, plug them in, see how it works. How would you actually set it up? And then go back and plug it in with unknown variables. That's a great way to help you build that equation. All right, so first thing, let's look at some keywords, right? All right, so first thing, to know that you are, well, I guess before I even talk about that, we should talk about what we're doing. We're solving, okay? We're not gonna talk about answering a question, right? If you look back at our notes, right here we had solving versus answering a question. We're going to talk about the solving, right? We already checked off simplifying, we already checked off evaluating. Now we're going to look at the solving part of it. All right, so when we're solving equations, keywords, things that are going to clue me into what we're supposed to do on the problem are things like this. Seems obvious, but you'll see the word solve. It'll say solve. It might say solve the following equation, okay? Those are obvious ones. Here's some less obvious. For what values of x? Right? And then it'll say, well, for what values of x does x squared plus x equal 10? It'll say something like that. But what you're looking in to look for is for what values of x. That's the key there. Okay? You might say something like this. If blank, then x equals. All right? If x squared equals 10, then x equals, okay? They'll give you the equation right here, and then they'll just say x equals. So that's cluing you into, okay, you need to find the value of x. You're solving, all right? You might see actual words like this. What is the solution? Or what are the solutions? To blah, 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 blah. That's where you'll see your equation. What are the solutions to this following equation? All right? And then this one here, which values of x, which values satisfy the equation? Which values of x satisfy, make the equation happy, right? We'll talk more about solutions, but to satisfy an equation means to make it true, all right? So satisfy the equation. All right, so anytime you see any of these keywords, also when you see a left side and a right side and an equal sign in the middle, and you see these keywords, that's definitely solving. And we'll go over some different strategies for solving in just a few minutes here. All right, so let's talk about solutions real quick. All right, what is a solution? Well, first of all, when do they appear, right? Well, solutions happen when we're solving. So when we solve an equation, we'll use EQN just to shorten it there. When we solve an equation, we find the solution. That's what we do, okay? The solution is what happens when we solve it, all right? Now, what is an actual solution, all right? Let's look at the definition of the word solution. A solution is any number that makes an equation true. I'm going to put or numbers because you could have more than one number, right? You could have an XY pair as a one solution, or you could have just a lot of solutions. You could have more than one number as a solution. There might be more than one number that makes the equation true. So a solution is any number or numbers that makes an equation true. Or that satisfies an equation, okay? That's another word to look out for. All right, so let's look at some examples of some equations, okay? All right, let's start with the really, really basic equation. 5 plus x equals 20, okay? 5 plus some number that we don't know has to equal 20. So I want the left side and the right side of this equation to be the same number. So what would x have to be? Yeah, x would have to be 15, right? So 15 is a solution. How come? It's because 5 plus 15 does in fact equal 20. It's true, okay? 20 does equal 20, that's true. So that number 15 made that equation true, so we're gonna say 15 is our solution, okay? Let's look at a number that's not a solution. How about 0? All right, 0 is not a solution. How come? Well, plug it back in. 5 plus 0 equals 20. True or false? 5 plus 0, that's 5. Does that equal 20? No, that is not true. So we say it's not a solution, okay? So basically what you're seeing here is how do you know if a number is a solution or not? You plug it into the equation. If when you plug it in, it makes it true, it's a solution. If when you plug it in, it doesn't make it true, it's not a solution. It's as easy as that. Now that works for one variable, two variable, one variable inequalities, two variable inequalities, any kind of equation, a system of equations. That's why I like that definition of a solution, because it covers all examples, okay? It doesn't matter what we're talking about. If when you plug it in, it makes it true, solution. If when you plug it in, it does not make it true, not a solution. So let's look at some more examples, maybe a two variable example. All right, this equation has two variables in it, so it's a two variable equation, x plus y equals 25. So let's look at one that's a solution. Remember, we're going to need two numbers in our solution because there are two variables, and we'll go ahead and put them as a coordinate pair. So let's say 15 and 10. Would that be a solution? Yeah, plug it back in. 15 for x and 10 for y. 15 plus 10 is 25, and 25 equals 25. That is true. Okay, 15 plus 10 does equal 25, so we're going to say that's true. That is a solution. Okay. All right, let's go back. Let's try another number set here. Pick any number, it doesn't really matter. How about negative, let's try positive numbers. 5 and 5, okay? If I plug in 5 for x and 5 for y, does it add up to be 25? No, which means that number is not a solution. So we're gonna say 5, 10 is a solution, 5, 5, not a solution. All right, next equation. Let's deal with maybe an inequality, okay? 3 plus x is less than 10. Actually, yeah, let's deal with it. All right, so the number 7, okay? Is 7 gonna be a solution? Let's try it. When we plug it in, we get 3 plus 7 is less than 10. That says that 10 is less than 10. Is 10 less than 10? No, that's not true. So we're going to say because 3 plus 7 is not less than 10, we're going to say that is not a solution. So 7 is not a solution. All right, pick a number like 0. Is 3 plus 0 less than 10? Sorry, I'll keep with I'll be consistent here. Now we're coming down on another example of 0. I don't know, let's try it out. 3 plus 0 is less than 10. True. 3 plus 0 is 3, which is less than 10. So we're going to say 0 is a solution. So actually, I'm going to erase that. I'm going to say, yes, 0 is a solution. Good to go. All right, excuse me. All right, let's look at one more example here. X plus y is less than 100. Okay, we're talking about another inequality here, but we've got two variables, so our solutions have to have two numbers. So let's look at the numbers 100, negative 5. Okay, x is 100, y is -5. When I plug that in, I add in a -5. Notice when I'm evaluating, I'm plugging it back in, I'm using a parentheses there. So if I use my calculator, I wouldn't get a wrong answer there. But if 100 plus a -5 is actually 95, and 95 is less than 100, so we're going to say yes, that is a solution. We're good to go there. All right, let's try 105. When I plug it in, I get 100 plus 5 is less than 100. Is that true? No, which means that that pair is not a solution. All right, it's easy as that. If you want to know if something is a solution, you just plug it in and see if it says something true. Things that are true: 10 equals 10, 5 equals 5, -2/3 equals -2/3. Those are all true. So that's what you got to do to check to see if something's a solution. All right. Don't forget with the inequalities, okay? When I had that x plus y less than 100, let's go back to that real quick. Was this the only solution? No. 101 would be a solution. Or excuse me, -1. 100 and -2, 100 and -3, 100. There's an infinite number of solutions. So with inequalities, almost always you have an infinite number of solutions. And we'll see here in a little bit how you represent that graphically. But just remember that. All right, so how do we organize our solutions, right? Mathematicians are notoriously lazy. We like to save time. Any way I can compress a bunch of information into a small idea, I'm going to want to do that, okay? So how do we organize solutions? Or how do I see them? Like where do I see solutions in math, right? So first of all, one way you see them is in graphs, okay? You see them in graphs. So I've got all these points here. Every single one of these dots, this coordinate, this location, every single dot on this line is a solution. Every single one. In fact, this line isn't really connected. It's actually just a bunch. It's so many points and it's so dense that it looks like a line. It's actually not really a line, technically. They're not connected. It's just an infinite number of dots that are so densely packed that it appears to be a line. And when I draw the line, it draws all the solutions. So every single point on the line, all points, we'll put all here, all points on the line are solutions. So when you see a graph, that's all it is, just a bunch of points, but it's really just a bunch of solutions, okay? Now, when you're talking about inequalities, right, two-dimensional inequalities, a lot of times we see this, okay? We'll see a line and we'll shade one direction. Okay, so basically all points on the line or in the shaded region are solutions. So this point right here, anything in this shaded region or anything on this line is going to be a solution. Now remember, if you're not allowed to be on the line, like if you have a less than but not less than or equal to, okay, just strictly a less than, you'll see that this shaded line or this line here will be dotted, okay, to indicate that you're not actually supposed to be on that line. All right, so graphing, that's one way that we're going to see solutions. Of course, with an inequality of one variable, you might see something like this as a set of solutions. So basically anything, this point, this point, this point, anything on that shaded region, if that maybe is 3, so 4, 5, 6, 7, those would all be solutions. So if there's an infinite number of solutions, we'll see it graphically, either in 1 dimension or 2 dimensions like we see there. All right, so another way we see solutions is with tables. Okay, this is for 2 dimensions when we have an x and a y number. So 1, 5, 2, 6, 3, 7. These are all solutions. So everything in that table is a solution. Right? Remember, solution is just a number that makes an equation true. So these pairs of numbers, like 1 and 5 together or 2 and 6 together, those pairs of numbers make that equation true. All right. Lastly, we're going to see it as coordinates. Okay. Maybe from the example above, I might see my solutions written like this. Okay. Again, those pairs of numbers are our solutions. And I guess you could see it one other way. You could see it as an equation. All right, 3x plus y equals 15. Basically, every number that makes this equation true is a solution. So you could kind of almost think of an equation as a way that we would represent a bunch of solutions. So if I had a bunch of solutions, I could write an equation. So yeah, I think an equation would be a great way to think about that as well. All right, so next up, let's talk about solving equations. Now, question, how do you actually solve an equation? Okay. Well, sometimes you have a really, really easy example like this, right? Where I can tell you what number x has to be to make this equation true. X has to be 15. That is my solution. Sometimes you can do it in your head. Sometimes it's really easy. Now, sometimes you can't, okay? 3.7x minus 10 divided by 2.3 equals 0.14. I cannot solve that in my head. Okay, so when you can't solve it in your head, what we're going to do is we're going to use algebra. We're going to simplify this thing until I can solve it with my head. So these, what we call inverse operations, right? That's what we're going to use here. Now, this is not PEMDAS. This is sort of different. There's some strategies that I think I've talked about in the intro course, the day 0 class, the prepping course, about how to actually solve equations, and you can look it up there. But inverse operations involve seeing how this is division, so we're going to multiply to get rid of it. Now, one thing is you got to follow the algebra golden rule. Whatever you do to one side, you've got to do to both sides. It's fundamental. You've got to do it. Anytime you're in algebra, if you do something to one side, you have to do it to the other side. Okay, it's like the golden rule for algebra. All right, so this is the most common way, right? Doing it in your head, not always a good way to do it. I mean, it's a great way to do it if you can do it, but sometimes we're going to actually use these inverse operations to solve for the variable. That's one thing you've probably heard your teacher say, is solve for the variable. Okay, what that means is we want it to say x equals and then a number. That's when we say we've solved for that variable. Sometimes teachers will say things like isolate the variable, get it by itself, right? Those are all ways that we can solve for the variable. That's just a strategy though. What we're really doing is just finding a number that makes the left side equal the right side, or makes the equation true. But that strategy of using inverse operations to get it by itself, that's a strategy. All right, so let's look at this example, because this is pretty common. Sometimes they ask questions on the ACT, they ask for weird solutions. Okay, now what do I mean by weird solutions? Well, for example, they might say, find x plus 3. Okay, they're not saying find x, they're saying find x plus 3. Now, of course, you want to find x first and then add 3, but that's a weird kind of situation. Also, they might say solve for something strange. Like they might say solve for a times y divided by b. They could say something like that. Okay, a times y divided by b. That is a strange thing to ask. Usually we're asked for find x or find y, but that's a weird thing to ask, but it's definitely something they can ask, so we need to talk about it. All right, and then they could say, they could say something like, what is x squared? Okay, basically they're asking you to find x and then square it, but it's another way to ask somebody to find a solution. So let's, so to do these things, we're going to follow algebra rules. Remember, add one thing to one side, you got to do it to the other. So we can do all of this by using these algebra rules. So let's look at what we're talking about here, okay? So first thing, let's look at that first example, all right? The one where it kind of said find, you know, x plus 3 or whatever it might be. So let's look at an example kind of like that, okay? So here's an example. All right, if 3x plus 40 equals 10, find the value of 2x plus 6. Okay, kind of seems like a strange thing to do, but it's very, very common on the ACT. Okay, so what we're going to do first is we're going to solve for x first. So we're going to use our algebra rules, right? I'm going to go over this pretty fast. If you need help with this, go back to day 0. I've got a video out there that's going to help with these kind of things. So we're going to take away 40. We're going to use the opposite of addition. Since we see addition, we use subtraction. That gives me 3x equals negative 30. All right, last step is to divide by 3 on both sides. Gives me negative 10. All right, that's my first step, was to solve for x. Okay, that's my first step. Then I need to find what 2x plus 6 is. So one thing I can do is I can just use my algebra rules, right? I can multiply both sides by 2. Taking this equation, and I multiplied both sides by 2. That gives me 2x equals negative 20. Okay, now all I need to do is get plus 6, because what I want is I want that 2x plus 6 to be on the left side of the equation. Okay, that's my goal. If I'm solving, if I'm finding the value of this 2x plus 6, I need it to say 2x plus 6 equals something. So what I'm doing is I'm building that. Okay, I had my solution here, but then I'm going to start building on top of that. So I need it to look like this. I need it to look like 2x plus 6. So I've got the 2x part. Now I just have to add 6. So if I add 6 to both sides, I get 2x plus 6 equals negative 20 plus 6, which is negative 14. So I know that 2x plus 6 is equal to negative 14. Okay? So what I did was, is if I'm asked to find 2x plus 6, once I solve, I make it look like 2x plus 6. Now I know this seems strange, because really once I have x solved for, I could have just plugged it in. I could have just taken this expression here and plugged in negative 10 for x. That would give me 2 times negative 10 plus 6, negative 20 plus 6, which is negative 14. Sure, that's an easier way, but this kind of shows you what we're doing here, because there's some examples when these variables, the ACT can force you to do it a certain way. So let's look at another example that's very similar to this. All right, so if 3x plus 3y, that's a 3, 3x plus 3y equals 30, find 2x plus 6. Okay, now first things, like I did, I want to solve for x first. So I'm going to get x by itself. So I'm going to take away 3y from both sides. That's going to give me 3x equals 30 minus 3y. Then I divide out the 3. Okay, now what I have to do here is I have to sort of distribute using division. All right, this is 10 minus y. So x is 10 minus y. What I'm saying is when I do this, when I divide multiple things by a number, I have to divide each part by the number. It's kind of like distributing, but so 30 divided by 3 is 10, and negative 3y divided by 3 is y. So I've solved for x. That's my first goal. Now I'm going to manipulate the left side of the equation and the right side, but I'm going to change the left side to where it looks like 2x plus 6. This is my goal. Take the left side and make it look like 2x plus 6. So how do I do that? Well, the first thing I have to do is I have to get 2x. So I'm going to multiply both sides by 2. So if I multiply the left side, which is x, by 2, I get 2x. If I multiply the right side, think about this. There's more than one thing happening. So I'm going to have to distribute with multiplication. So I get 20 minus 2y. Okay, I'm almost there. Remember, my goal was to make it say 2x plus 6. I've got it saying 2x. I just need to add 6. So if I add 6 to both sides, I get 2x plus 6 equals 26 minus 2y. And that would be my answer, 26 minus 2y. Now remember, that's a little more abstract because it's not just a number, but that's the strategy there. Is sometimes you're asked to find weird solutions. So instead of saying what is x, they could say what is 2x plus 6. Well, there's a way to do that. This example shows you how to do that. So let's look at one more example. All right. If 3a is equal to 10p, then find ax divided by y. Okay, so what I want is I want the left side to look, I want to change it to where it says ax divided by y. Okay, I want to manipulate this 3a until it looks like that. So I'm just going to get rid of the 3 first. Okay, I can take 3a equals 10p, and I can divide out that 3. That makes the 3 go away. Okay, that leaves me with 10p divided by 3. Now, how do I get it to have an x multiplied by the x, or excuse me, by the a? How do I get it to say ax? I just multiply by x. Multiply by x, multiply this by x. That gives me ax equals 10px divided by 3. You'll have to excuse these little things here. All right. Okay. Now, I'm almost there. I just need a y to be divided by. So all I do is I divide the left side by y. And when I divide the left side by y, I get 10px divided by 3y. All right. I know that's a tricky problem, but it's totally doable. If you just remember that when you're solving, you just make the left side equal to whatever you're solving for. And you can do anything you want with algebra. I could add 10 to both sides right now if I wanted to, but I don't want to because I don't want to have a plus 10 there. But you're allowed to do anything you want as long as you do it to both sides. So if you need to change something to make it look like something else, that's the strategy you're going to use to do it. All right, that's all for week 1. Thank you guys so much. There's going to be a homework assignment, and you need to make sure you do it. It's about an hour's worth of practice problems. I will present a problem, you'll work through it, and it's really, really important that you do those because the practice is what's going to really make sure you're able to do these things. I can show you all day long, but if you can't do it, then it's not going to work. So thanks again, and we'll see you guys next week. All right.